Zombie apocalypse.
Okay, so today's topic is double integration method as a principle. So before we try to solve problem, of course, we need to understand first yung concept behind this topic. So let's get it to be neuralized. Okay, the discussion for today has a reference and it was taken from Hibbeler, no? Structural Analysis, the 9th edition, as shown on the upper left. So that it would serve as a source, a reference source, no, for our discussion for today. Although this is actually derived from strength of materials, but I need to, of course, identify the references. Okay. Now, suppose that we have this beam loaded with different types of load. Let's say a distributed load of identified degree, and let's say a concentrated, or even though there is a moment, kahit maglagay ka pa dyan, let's say a moment m of whatever value, there's one thing that will happen to the beam. It may deflect like this, most likely the case where gravity loads are applied or towards Earth, or maybe pwede yan titawag na ano, no? Double curve. So this one, the one that the beam will suffer a red line, a red colored curvature is what we call single curve, no? Single curvature yan. Okay. Single curvature. And sometimes, pwedeng mangyari is ganito, double curvature. So, parang nangyari, merong association, depende sa load nature na in-apply. Kasi the load may change the direction of the deflection and some rotations. Okay? So, this is what we call double curvature. Okay? Okay? Now, so what is the phenomena that is happening here? Of course, the deflection or the rotation. So let's say this is what we call rotation. Let's say at point A. So measured from the horizontal. Okay, there's theta. Sabihin sub A. Also, let's say in B. Of course, with respect to horizontal and a tangent line. So meron kang titawag na rin theta B. Likewise, on point C, assuming medyo umangat na siya, okay? So, meron din dito tinatawag na theta C. Of course, magkabilang angle yan, okay? So, we can call it as, ito yung tinatawag nating quadrantal angle, o first, second, third, and fourth, okay? Now, reflection is also a part of the analogy, okay? Now, of course, if the beam suffers from bending, okay, so there's what you call resistance to moment, okay? We know that in the past discussion, if the beam bends like this, a curvature that goes, the concavity is going up, so deflection is said to be downward. If there's a positive moment, okay? Also, it was stated in second materials also, if the beam will deflect like this, so this is what we call negative bending on the other hand, and the beam will deflect upward, okay? So this is just only a representation of possibilities of it suffers positive bending or maybe negative bending. So, but the concept is, why does it bends like that? Of course, with respect to the property as illustrated earlier, there's what we call elastic curve positioning. So that is the measurement of the sudden change in the slope for every point with respect to the horizontal axis. Now, for every curvature means there is a possibilities of a radius that might be considered. So represented by rho, okay, with a common center, let's say O prime. Then as we analyze this length, that is what we call ds, okay, and representative of differential strip length x, so with respect to horizontal, and of course possibilities of that differential change of the angle, which is the theta, measured from the original tangent line up to the next tangent line. So as we get a strip of it, let's say this one, we try to analyze. So there will be some changes that will happen. So illustrating the same. So there will be, parang i-analyze po natin, di ba naka-curve siya, no? As if this is just only a straight line. So most likely, ds will be just only way equivalent to dx, no? Parang ganyan ang mangyari kasi ito yung length ds. And then this is just only dx. So almost they are the same. The reason is the theta is too very small. Okay? So therefore, we accept that the theta with respect to dx, or also known as y prime, is also too very small, all or approaching 0. But there's a value, no? Hindi na siya sakto 0 So almost 0 siya, tolerable, but we will not neglect it because it has a value. So by this, we need to consider the radius of curvature. So stated with the change of length strain condition, so ds prime minus ds over the true distance, okay, the length itself. Where we already consider that ds is also dx almost kasi to very small, as mentioned earlier. So raw data, no, raw d theta. So, paano nangyari? Para ka na lang may equation na ito. Pero actually, rectangular na yung treatment. So, taken from your strength of materials, so also an area. So, we need to understand the strip x. So, magiging x na lang yan na magiging the radius times the angle, where the radius here is stated as rho. So, whereas the ds prime is the change in the attribute of length. Kasi paano nangyari? The rho is already in the axis of y itself. Okay? That's why we arrive to this equation. Okay? Note that strain is the strain changes, okay, over the original. Parang ganyan ang konsepto niya. Where this is already in terms of a value set. Okay? So now, as we take it on a closer look, so we will get this. So this is one of the popular formula derived on the equation of Hooke's law of axial deformation. Also, we already identified due to the moment, no? So it has a relation of sigma is equal to EE. So as we take a look and then take that into consideration, so as we supply this equation, the MC over the R, the MY over the I inside, so papasok mo lang dyan, and then we will arrive on this statement. So EI is said to be again the flexural rigidity. Tawagin natin F sub F dot R dot, okay? So moment as the moment flexure, okay? And rho serves as to be the radius of curvation or curvature of the given segment. So these are the terms that I'm talking about earlier. So note that in the I is the beam of inertia as computed about the neutral axis. It is can be taken as the stronger or the weaker. Usually, kapag ang beam natin is patayo, of course, this should be the weaker, or rather the stronger, and this should be the weaker. Or in the other sense, this is the function of x, about the x, and this is about the y. Okay, so since we know that dx is equal to rho d theta as stated earlier, and then by simply injecting, plugging in that formula, then we will arrive to this. So this is actually the one of the most the commonly used equation in understanding double integration method, but it's just only the one of the sets. Okay, so meaning the slope is a function of moment with respect to its flexural rigidity as a distance, as a function with a distance. Okay. And again, based on calculus, so this one, we already know this, before that this equation represents the points of inflection, but raised to 2, okay? And the dv over dx represents the slope, y prime, okay? V represents the vertical and x represents the horizontal. So, again, when the angle is too very small, y prime is also too very small, okay? Since that is dy over dx. But in this setup, y is being represented by v. So, setting up y prime to become 0, kasi nangyayari dito is the theta in degrees, okay, is most likely near to the value of theta in radians. So, parang we need to convert it right away. Okay? So, possibly, yung theta in degrees mo, when you convert it into radian, okay, so it will be automatically equivalent to a value of theta na almost equal na sila. Okay? So, by replacing that, so we will understand that m over ei will be just only equivalent now to 1 y double prime, okay, over 1. Whereas y double prime is just simply saying 1 over the rho. Okay? Kasi yun na nangyari dito sa setup na ito eh. So, therefore, as we understand that, and then rho is just only the setup. So, para nangyari, sinalpak-salpak na lang natin. So, we will get this one. So, therefore, the second order derivative, okay, let me rearrange this over this one, no, second order, or m over ei. So, I want you to focus on these two equation. Meaning, there should be two constants to consider kasi dalawang beses kang mag-integrate dyan, while this one should be a constant, no? So, meron kang tinatawag na arbitrary constants to be eliminated. As a rule of differential equation, no? These two constants should be understood well and should be evaluated based on the property of wave that we have. Will it be statically determinate, simply supported, or statically determinate with or with overhang, single or double, or maybe for under indeterminate. So indeterminate is also a case issue of double integration principle. So of course, procedure of analysis, so you can try to read this, and this will be our this will be our guiding light in solving a problem related to double integration method. Okay, so these are the procedures. So to cut it short, you can read it, no? So I assume that the viewers or learners will try to read it all, and I'll try to highlight so what should be done. So under this, the elastic curve should be understand based on the property of supports. Okay? So sabi na po dyan, kapag hinge o roller, ang property po kasi ng slope natin, say y prime, is 0. Is not 0. It has a value. So, ibig sabihin, it should reside with a value. While the y or the deflection, so ito understanding natin para mas madali. Okay? So, magde-deflect yan. So, basta pag nag-deflection, sabihin natin y. At kapag may slope, siya yung y prime. Okay? So, y prime is given on a hinge roller kasi it allows rotation while the displacement or deflection is said to be 0 unless the supports are yielding. So, but for the meantime, we will assume that the supports are not yielding. So, slope is just only allowed. But for the fix, okay, both y prime and y are held 0 because the slope, okay, will not be allowed do sa ating support system, okay? So dito, pagka nagkaroon ng bending yan, diretso, tapos gaganyan. So pag nag-tangent line ka dito, horizontal lang din. So settlement will not be also allowed to this point. So therefore, y prime and y are both 0. But of course, if you have an overhang, for example, the tip of the overhang will deflect, okay? Parang ganyan. Okay? So both of them, y prime and y are present. You should have both values. So sa support system dito tayo magpo-focus, okay? So this will be the evaluator of our arbitrary constants. Okay, ganun din, you have to write the moment equation. However, the moment equation that should be understand should be continuous with respect to the cutting plane. Ang gagawin po natin is ganito, para to simplify this rule. Kahit may overhang ka man o wala sa dulong kaliwa, what you're going to do is this. You always get the leftmost part, whatever the location, kahit may support o wala, and set that into a y and then a coordinate of x-axis, so where this be the 0, 0 coordinate. And of course, the supports will follow, statically determinate or indeterminate. And then, we need to adjust with the system, lalo na kapag we need to pass a cutting plane. For example, I'll try to give you a short example. Okay, let's say we have the 0-degree load. So there's a need for us to cut on the last cutting segment. So ang last cutting segment, yung pinakadulong kanan naman. Whatever the location, kahit may overhang o wala. Sa ulitin ko, yung unang dulo sa kaliwa, yung kukulayan ko ng violet, laging dulong kaliwa yan. Yan yung 0, 0 coordinate natin. Ang reason kasi para yung distance x mo, wala kang i-accept na negative. Otherwise, be careful that if you set it, let's say, on the support hinge, magkakaroon ka ng negative distance na acceptability kasi meron ka overhang sa kaliwa. Parang ganun. So, to play safe, dulong kaliwa with or without overhang should be a coordinate 0, 0. And then, that should be the reference distance of x. Patatakbi mo sa last cutting portion. Na yung last cutting portion, segment 1, 1, is yung nasa dulong kaliwa, dulong kanan naman lagi. Dulong kanan, meaning ito ang laging last portion. Okay. Ngayon, pag ang load natin is nakadikit sa cutting plane, okay lang, walang problema. However, this one is hindi nakadikit. So, kailangan nyo i-continue. So, let's say if you have this, tapos nandito yung cutting plane mo, so, kailangan mo i-maniobra yan. Hindi nakadikit ito eh. Ang ruling kasi dapat, the load should be continuously touching the cutting plane and or should be increasing. Okay? Or, not the word or, it should be always, no, and increasing. So, therefore, geometrical reorientation will happen. So, gawin nyo, i-continue lang yan. So, parang may nakikita na kayong isang buong ganito na pababa at may pataas na equivalent. Okay? A reason is, forces are the same but the deflection is continuous pa rin kasi kahit walang load. Hindi porket walang load, wala ng deflection. Ibig sabihin, the load is suddenly missing, no? So, therefore, ganyan po pa ang gagawin natin kapag may mga discontinuity na 0 degree. For first degree naman, for triangular, let me illustrate this. Okay? Tapos, dito ka nag-cut. Let's say, hindi na dugtungan. I-continue nyo lang po yung slope. So, lagay nyo po ng parang mirror image na bumabalang. Ayan. Kasi yung shape na to, tsaka yan, same lang. Of course, if this is W, sabihin na natin may Z do, okay, ito rin W and Z. Kanina dapat na para sila ng magnitude, W yan, W din yan. So, pababa, may equilibrium din naman na pataas. Okay? So, ganun din. So, mangyari is ganito. Mabubuo mo na itong triangle, okay? At dito may konting trapezoid ka. Okay? Yan. Tapos ito yung isa pang triangle. I'll try to color in blue. Dark, in green. In blue, yes, light blue. Yan. So, dyan ka na mag-establish ng moment equation mo. Pag hindi nakadikit sa loading. Ngayon, pansinin nyo po dito sa pangalawang illustration ko. Okay? Ito to. Yan. Ang load natin dapat increasing. First degree, second degree, okay yan. Pero paano pag ganito ang nangyari? Naka-opposite siya, no? Kunwari, say, ito to. Sabi nga natin, di ba? Kailangan ang cutting plane nakadikit do sa load. Okay, let's say, nandyan. Nakadikit, yes. Increasing by load, no. Tandaan nyo, ating cutting plane natin, 1, 1. Eh, hindi naman nakadikit, right? So, therefore, itong area na to, nakadikit siya pero hindi siya increasing. Decreasing nga eh. Pababa siya, approaching 1 eh. So, what you want to do here in this situation is, ituloy nyo to as 0 degree. Parang, hindi siya 0 degree. Diretsuhin mo. Nakikita nyo ba itong area na ito? Para may triangle sa baba. Ilagay mo sa baba. Okay? So, therefore, equal magnitude sila. So, if this is W, this is also W. So, mangyayari dyan. But, sabihin natin, delta W nga pala kasi ito yan. This is delta W. Okay? So, nakikita nyo lang is ganito. So, naging buo na yung rectangle sa taas. Tapos, meron kang triangle na lang sa baba. So, dapat po increasing. Increasing po ba? Yes. Notice that the slope nito is increasing. That is touching the load cutting portion. So, yun nga lang nature niyan, pataas na po ito. Ito naman ay pababa na trapezoid. Okay, ito yung trapezoid na pababa. I'll try to draw in violet. Ayan, yan, ito, yan. Hindi drawing ko ng violet. Okay? So, load yan is pababa. Okay? Yung triangle naman sa baba is pataas. Parang ito yung load niya. May arrowhead ka na pataas. Okay? So, yan yung isa sa mga rule to follow. You cannot proceed with the moment equation if the load, all loads are violating this rule. Lalo na mga 0 degree up and higher. So, in short, 0 degrees should always touch the cutting portion, and if not, do the what we call reorientation of the geometry, okay, o load geometry. Tapos kapag first degree, kailangan increasing lagi ang degrees niya papuntang cutting plane. Pag hindi increasing, gawa natin ng way, katulad ng last kong ginawa. At kapag hindi man nakata sa cutting plane, just continue the slope and then try to apply some mirror images para kung ano load sa baba, taas. So, yun nga lang, pag ang load sa taas, pababa. At ang load na nasa baba ay pataas. So, tandaan nyo, lahat ng load na nailagay sa taas ay ang nature na yan ay pababa. At ang load na nasa baba, ang nature niyan lagi ay pataas. So, concentrated and moment loads eh hindi kasama sa itong load. So, dapat ano lang, gawan nyo lang ng moment equation. So, before I end this up, so sign convention nga pala muna. So, sign convention po natin, kapag deflection po, okay? Deflection. So, pag bababa, positive yan. Kapag pataas, sorry, it should not be like that, baliktad. So, pag pababa, alam natin, negative, yan. Kapag pataas, positive. Anong reference guide ko? Use the Cartesian coordinate. Yan lang naman. Ang deflection kasi found on the vertical axis eh. Alam natin, pag pataas, positive ang coordinate, pag pababa, negative. So, ganun din guide. Lalo na kapag x natin, lagi tayong pakanan, no? Kasi sabi natin, dulong kaliwa, papuntang kanan. So, wala po tayo i-accept na negative x. And likewise, sa slope, tingnan nyo lang po yung quadrant. So, alam nyo naman, positive ito, positive, negative, and negative. So, kapag ang angle natin is positive, so of course, these are the positive angles, first and third yan. Okay? So, kapag meron katitawag na negative angle na nakuha, so it is being located on the second and or the fourth. Okay? So, that will be serving, that will be our guide, no, to the angle theta direction. Very important kasi na malaman, lalo sa paghanap ng maximum deflection. So for this section viewing, I hope to see you in our next video lecture. So I will now try to demonstrate some sample problems regarding this. Illustrating with simple span, illustrating with double overhang, doon ako dediretso, and also illustrating indeterminate beams. So okay, so by this, you have been neurorized as our tradition, and see you in our next video lecture.